Hello learners, today we are going to solve a problem on square pyramid. The statement of this problem is like this. A square pyramid of side of base 40 mm and height of axis 75 mm is resting on HP on its base with base edges equally inclined to VP. An axial circular hole of diameter 25 mm is punched in the pyramid. Draw its projections and develop lateral surface of the pyramid. So, the edges of the square pyramid, base edges of square pyramid are equally inclined to VP. So, we have to first draw its top view with the base edges equally inclined to vertical plane. Now, by this time you might have understood there are two possibilities that base edges may be perpendicular to VP or they may be equally inclined to VP. So, accordingly, if it is perpendicular to VP, we have to draw its top view like this. If the base edges are equally inclined to VP, we have to draw its top view like this. So in this case, we have to go for this second option, base edges equally inclined to vertical plane. So this is the way we have to draw its top view with given edge of base, which is equal to 40 mm and height of axis is equal to 75 mm. Let us draw its top view front view. Now in the problem statement, it is mentioned that a axial square hole. So hole or axis is coinciding with the axis of the pyramid. So axial square hole of diameter 25 mm is cut in the square pyramid. That means that hole will be seen to its true shape in top view. That's why we have to draw a circle of diameter 25 mm so that its axis and axis of the pyramid both will coincide with each other. Axial square hole can be treated as a cutting plane. This is a curved cutting plane in this case. So this circular hole is nothing but a curved cutting plane which cuts edges of the pyramid at these four locations. But if you observe in this case, before we go for the development of this surface, here we see that if you consider this point, after this point there will be directly this point. So there will be a large gap as far as these points are concerned. Also their distance from the apex are different. Distance of this point from apex and say point somewhere here is different. That means the curve is going to be obtained such that some points will be obtained at some higher height from the base while some points will be obtained at some lower height. To consider all these points on the development, we have to consider some additional edges on the surface of the pyramid. So now I have considered these four additional edges. I will name them as E, F, G and H. So these are four are the additional edges considered on the surface of the pyramid. Now we have to start developing the lateral surface. Before we develop the lateral surface by using radial line method, we have to always ensure that the edge, that is O dash C dash, is to the true length or not. For that, a very simple check, I again repeat here, whenever any one view of the line is parallel to xy, say one view of the line is parallel to xy, other view always indicate its true length. So say this view is parallel to xy, other view always gives true length. So just see in top view, edge OC is parallel to xy in top view. That's why O dash C dash indicates its true length. So there is no need to go for any extra construction. We can directly use O as center and OC as radius and draw a radial line. Now just to differentiate the points on the front view and the points on the development, I am starting developing the surface from some distance from this edge OC. Draw radial line. Now along this radial line, mark the base edge. Now let us say I start developing surface from A Now on the developed surface, I have to mark those extra edges, that is E, F, G and H. Now here for convenience, I have taken E at the mid as a midpoint of AB, F as midpoint of BC and so on. So take distance equal to half the base edge and go on marking points E, F, G, H. You can see E is between A and B. So between A and B I get E and respectively F. Join these extra points with the apex. Now let us consider common points to the cutting plane and the edges of the pyramid. Before we obtain these common points in front view, first obtain those extra edges. Name the extra edges. Now next we have to obtain those common points on the edges of the pyramid. Now we have to mark points on the edges. Point 1 dash is on OA. So I have marked 1 dash on OA. 2 is on OE. So you can see OE, here you get point 2. Now here you will observe that the distance of points 1, 3, 5 and 7 is same from apex. I again repeat, distances of points 1, 3, 5 and 7 are same from apex. That's why all these points will be obtained at a certain particular height from base or from certain distance from apex. Similarly, distances of points on extra edges. The points on extra edges are 2, 4, 6 and 8. All these points are also at equal distance from the apex. But we observe here that point 8 or all these points with even numbers, they are at larger distance from apex as compared to the points on regular edges. Points on the extra edges will be at larger distance from the apex and points on the regular edges will be at the lower distance from apex, and they will be at same height as far as distance from base or distance from apex is concerned. So here accordingly we will get 1 dash, then you will get 3 dash, here you will get 5 dash and here 7 dash. Similarly here 2 dash, then here you get 4 dash and 6 dash, and here you get 8 dash. So this way we have obtained all the points on the front view. Now the remaining part is to obtain all these points on the development. So first draw horizontal lines and then with O as center and this much as radius draw arc. Obtain points on the respective edges. I start from 1. So 1 is on OA. So here you get 1. Then 2 is on OE. So we can see here you get 2. 3 at this height, and on edge you can see 3 is on OB. So on OB and at this height you get 0.3. Likewise, if you go on marking the points, you will get them sequentially like this. Now we have to join all these points in sequence by an appropriate curve. Here pyramid is a plane surface. Pyramid is a plane surface and plane surface is cut by another curved surface. So definitely the line of intersection is going to be a curve. So this is the part which is cut because of that circular hole. Now here again this top part is assumed to be removed because of cutting of the hole in the pyramid. This top portion will get removed and the bottom portion we have to keep or we have to retain, and that's why it is to be shown by thick line. So to differentiate thin line and thick line, I have intentionally made the retained part by yellow color. So yellow color here indicates that this part is to be drawn by thick lines, while all other edges like white and here green, they are to be drawn by thin lines. In front view also you can see, because of boring of the hole, the front view of the pyramid will look like this, while in top view it will look something like this. So in top view also we have to draw this base part thick and the whole part by thick lines. In front view also the part below this hole and regular edge, this is regular edge, this is regular edge, and this is regular edge. So this much part is to be made thick, and of course base is also to be made thick, while upper part containing apex is to be kept thin. So this way we have drawn top view, front view, and then development. The final point remaining is dimensioning. So this completes projections of this pyramid